Hi, my name is Milad Yakani. I'm a PhD candidate of neuroscience at Tehran University of Medical Science. Today, I want to speak about week 1, day 2, tutorial 4, section 2, which is about polynomial regression. Sometimes the relationship between our dependent variable and independent variables is not linear. And for example, you can imagine that we are presenting a stimulus with different intensities, and then we are recording the firing rate of a neuron. And the relationship between these two variables follows this equation, which is y equals x squared minus x minus 2. And we can generate our data by injecting some randomness to it, which this code is doing this. And then after visualizing it, we immediately notice that we cannot fit a line to it. And the relationship between x and y and also depends on the value of x. As we increases x, the behavior of this relationship changes, and it depends on the value of x. What we call nonlinearity. So we cannot describe these kind of relationship by simple lines with a fixed slope. We need to have some curved thing to fit to the data and describe it. And here the curved thing is our polynomial. Polynomials are terms of our variables raised to the power of some integer, for example, x to the power 0, power 1, power 2, and then multiplied each of them by a coefficient, and then add them up, we can have our polynomials. And here if we want to fit a polynomial, we can use the previous methods, for example, ordinary least square method, but we need some different design matrix. Our design matrix here should encounter the power terms, and the first step here is to create our design matrix. Here in the coding exercise 2.1, we can see a function which is getting our x's in a vector form, and then and also it gets the order of the polynomial that we want to fit, and then generate our design matrix. Okay, let's comment this line out, and here you can see the first column of the design matrix. It is x to the power of 0, which is 1, and we can generate it. We don't need to calculate it. What we need is get the x vector and raise it to the power of the degree that we have here. Okay, and also we need to stack these columns with previous columns, which is inside, okay, inside our design matrix. Okay. So it is doing this until it reaches to the order of the polynomial, which is the highest power. And you can see here we have the similar answers, and our code is working correctly. I encourage you to play with the code and see other terms, for example, x squared, x cubed. And I hope you enjoy it. If you have any question, please ask.